Okay, in this video, we're going to look at one other technique that's called factor by grouping. And this is not something you can use all the time. It's kind of a specialized case. And you got to realize some polynomials just flat don't factor. But if you happen to have four terms, this is something you may want to try. And it might work out to be very easy, maybe not. In this polynomial, we have four different terms, and none of them are like terms that can be combined. Now I have the latitude where I could switch some terms with each other. I could move the 4x squared and the 3x to different places. I could switch the 12 over in here. I can rearrange things however I want. And the reason I say that is sometimes you need to rearrange things to fit what you're trying to do. So as you look at the pattern we're going to try to apply to this problem, think about whether or not something might need to be arranged in the future to make this happen. Now, factor by grouping basically says this. I'm going to take a look at the first two terms in my list of terms here, and I'm going to factor those without worrying about the other two. And I'm going to hope that this works out the way I want it to. So I'm going to look at this term, and I'm going to ask myself, what do these have in common? And the answer is they both have at least an x squared. Now, if I take out that common factor, kind of like the distributive property in reverse, I'm going to be left with an x minus 4 in parentheses. Okay, now I haven't really done anything huge yet. I've just sort of taken the first two terms and written them differently. Okay, now, I'm going to ignore what I just did, and I'm going to write the next two terms right here in factored form. So I'm going to take a look at negative 3x and positive 12, and they have some things in common. I could take out a factor of 3, or I could take out a factor of negative 3. They both share those factors. Now, how do you know which one to do? Well, once I show you this, we can look back in retrospect and see why I picked it the way I did. I am going to take out a factor of negative 3, and here's the reason. If I divide both of these terms by negative 3, this will become a positive x, and this will become a negative 4. Okay. Now, the reason I wanted to do that, hopefully you can see this, is that factor and that factor are exactly the same. Now remember, these factors, it's easy to lose sight of the big picture here. X minus 4 is just a number that I don't know. The nice part about this is this x squared is attached to a number I don't know, and the negative 3 is attached to the same number that I don't know. Now let's just stop this problem for a second, and I want to show you a side note. If I had 5 times 7, two numbers that I could do in my head, plus 5 times 2, would it not be possible to just write this as 5 times 7 plus 2? Wouldn't the distributive property basically say that that's the same thing? Okay, now right now it's hard to see because of all these variables, but what we really have here is a number. Like down here we had 5 that was multiplied by two different values. Well, here we have a number. That number could be 5. We don't know what it is yet, but it is the same number and it's multiplied by two completely different things. What I'd like to do is write it this way. Okay, so what I'm going to do is say, okay, I'm just going to take x minus 4, whatever that is, and I'm going to write x minus 4 one time. Same way I did down here. Okay. And then what's left over are these numbers. See, these were different numbers that were both multiplied by the same thing. Well, here I took the same thing, which happens to be x minus 4, and I'm going to multiply it by the sum of the two numbers that were different. In this case, this and this. So I'm going to multiply it by x squared minus 3. Now, that's a little tough to follow. This whole process right over here is not easy to grasp at first because it looks so different when you have variables in there, but it's still just the same thing. And if I look at this now, if I were to FOIL this problem out right here, let's say I took those two binomials and I did my FOIL process, guess what? It's going to be the same thing as these four terms up here. No like terms will be able to go together. There won't be anything that has the same variable combination with the right exponents to put together at the end. So my factored form now, rather than having 4 separate terms like I do right up here, I can write it this way. X minus 4 times x squared minus 3. And if at some point I have to solve this within an equation, it's much easier to deal with like this in 2 separate groupings than it is 4 different terms all spread out.